Welcome back to Code and Conquer Daily, where we solve a new LeetCode problem every single day. If this helps you out, please hit the like button, share it with a friend, and subscribe so you never miss tomorrow's solution. Today we're tackling problem number 1563, Stone Game V. LeetCode problem number 1563, Stone Game V. There are several stones arranged in a row, and each stone has an associated value which is an integer given in the array stoneValue. In each round of the game, Alice divides the row into two non-empty rows, i.e. left row and right row, then Bob calculates the value of each row, which is the sum of the values of all the stones in this row. Bob throws away the row which has the maximum value, and Alice's score increases by the value of the remaining row. If the value of the two rows are equal, Bob lets Alice decide which row will be thrown away. The next round starts with the remaining row. The game ends when there is only one stone remaining. Alice's score is initially 0. Return the maximum score that Alice can obtain. For example, given stoneValue equals 623455, the expected output is 18. The brute force approach involves trying all possible divisions of the row in each round and calculating the maximum score that Alice can obtain. However, this approach is not efficient as it involves a lot of repeated calculations and has a high time complexity. The complexity here is 2 to the power of n. The optimal approach involves using dynamic programming to store the maximum score that Alice can obtain for each subarray. We can calculate the maximum score for each subarray by trying all possible divisions of the subarray and calculating the maximum score that Alice can obtain. We can then use this information to calculate the maximum score for the entire array. The complexity here is n squared. Now let's implement the optimal solution in C++. I'll write it out step by step so you can follow along. Initialize the prefix sum array. Initialize the dynamic programming table. Fill the dynamic programming table for length 1. Fill the dynamic programming table for length 2. Fill the dynamic programming table for length 3. Fill the dynamic programming table for length 4. Fill the dynamic programming table for length 5. Fill the dynamic programming table for length 6. Return the maximum score. Thanks so much for watching. If this helped, give the video a like, share it with someone who's learning, subscribe to the channel, and ring the bell so you never miss tomorrow's LeetCode solution. See you in the next one.